Yeah, I think, Marta, you can slowly start. We have, I think, Lydia, which is from Ruđer Bošković Institute, if I remember well.
Yeah.
So welcome, Lydia. And it will be a bit more intimate session because I believe that people are maybe already on the seaside or or they are having the coffee. So let's start, Marta, I would say,
Yes.
and we can then expect some more participants on the way. So I will just give you a little introduction to the to Marta, which is actually the field application specialist for Nordics. I'm cooperating with Marta already a few years, and I'm happy that today she actually is contributing to our educational webinar about spectral cell sorting. So thank you, Marta.
Thank you, Ricardo, for introducing me. Hello, everyone. Very nice to at least meet you. And yeah, let's start. Today, as Ricardo mentioned, I would like to give you an overview on our Aurora cell sorter, which is already on the market for a few years, but there are some new features on it, which I will highlight during my presentation. So first, what I would like to start with is, of course, the introduction, what we have on our system, what it is. Aurora Cell Sorter is a spectral sorter, which till last year was available on 3 laser configuration. Since this year, we broadened the possibility with possibility when it comes to the optical configuration, meaning that user can already start with the sorter having only 1 laser. So 1 and 2 lasers configuration, these are the new features on our system that allows our users who have northern light to have perfect match with the analyzer. Additional feature which is quite new on the cell sorter, which was already available on the analyzer, is the possibility to select different mode for work, meaning that the user on cell sorter can select either I want to go for spectral or conventional modes. So both have benefits. Both, of course, give you some feature which you can use, like, for example, when user will decide to stay with the full spectrum mode, of course, can benefit from all the features which that mode brings, meaning, for example, working with autofluorescent or multiple autofluorescent, we can here in that mode stay or work with more complex panel, having more colors. We have higher flexibility also here when it comes to the fluorochrome choice. If for certain reason user will select the conventional mode, which, by the way, the conventional mode was developed by Cytek people based on the feedback from users, that some of you you prefer to have kind of a fast, quick mode for simple visualization of the samples. Sometimes you also work with samples where you don't need the unstain. And maybe those of you who are working with our spectral systems knows that when you want to use the spectral mode, you have to provide the unstained sample. Yeah, the conventional mode is kind of as on the conventional system. So if you have a simple assay where you do not have unstained sample, this is something that you can work also on our system without the unstained sample. Another feature which is now available on our cell sorter, it is something what we call enhanced small particle detection option, which some of you maybe are already familiar because you heard that option, that module is already available on our analyzers. Since this year, it is also on our cell sorter, making it again matching the analyzer. Yeah. So what that ESP module gives you, it gives you improved resolution of small particles. So you can see that as on the left side, we have the outcome of data from standard system. meaning with normal side scatter, which we provide, and you can resolve 90 nanometer bits from the background. However, if you would use the system equipped with this ESP module, the resolution is improved, yeah, so you can benefit more. I can tell you that with the ESP module, you can even go down with the size of bits to 70 nanometers. So now that is also doable on cell sorter. At the end of my presentation, I will also show you that we at Cytek perform some sorts with EVs, and I will show the example. So what are the benefits of the full spectrum profiling technology, which, as I said, some of you maybe are familiar because you are working already with the analyzer. You have a possibility to work with a lot of different applications on our system. That spectral technology gives you the higher flexibility choice when it comes to the fluorochrome. You can select, combine very similar fluorochrome to each other. You can also benefit from the autofluorescence. Yeah? And what I would like to also highlight that with the newest version of software, now it is also possible to work with multiple autofluorescent within your experiment on the cell sorter, meaning that, of course, we need to provide downstream, so the user needs to stay in the full spectrum mode. And then when you will do right click, you have access to autofluorescent Explorer, AF Explorer. So new wizard will open with the list of points to guide you what you need to do to be able to work with the sample which you expect or you already maybe see, you know, that has multiple autofluorescent. Not only the autofluorescent, but on our cell sorter, you can sort from raw or unmixed data. You know, maybe from analyzer to those of you who first time hearing about Spectral from Cytek, when you are recording your data, you are collecting raw data, but also unmixed. So on the cell sorter, you can, as an operator, select which data you would like to use and sort from. Also, very important for us was when teams at Cytek were developing the cell sorter that the part of the dedicated for sorting will be also user friendly and very intuitive as our spectral flow. So with that, I would like to show you the capabilities of our cell sorter. So you can acquire sample from 5 or 15 ml tubes. You can mix if that is a need of you. Sample, either the input sample or collecting sample can be warm up or cool, depending on the application. You can sort different ways. So we can sort into 6-way 5 ml tube, 6-way Eppendorf tubes, 4-way fax tubes, so 5 ml tube, or you can perform 2-way sort into 15 ml Falcon tubes. Also, of course, plate sorting is possible together with the index sorting for both type of size of the plate, 96 well plate or 384 well plate. To perform the sort, you can select different nozzle and different modes, depending, of course, on the cell size and the downstream application. Yeah, so we can select between 70, 8500 and 130 micron nozzle. And here is the list of the default modes where, of course, user operator can create their own mode as well. The sorter is coming with built-in aerosol management system, meaning we have built-in HEPA filters. So if, unfortunately for the operator, during the sorting, some aerosols would appear, sorter will be sealed. So all doors will be sealed, protecting the operator from inhalating those aerosols. And after a certain period of time, of course, once all the aerosols are removed via the HEPA filters, operator can open the doors. The sorter can be also placed in hood or biosafety cabinet if that is a need or regulation of your laboratory. So now let's move to the workflow. What are the steps that allows us, or we should, of course, perform before sorting, and how sorting looks like on our system. So first thing what we need to do is instrument setup. We start up the system, we should check the break-off point. So we should see that the stream, the first broken off drop has a stable position. We need to also do the daily QC. This is something what I hope you all are doing on your instrument, which you have at the moment in your laboratory. Next step will be the experiment setup. When it comes to the sorting, before sorting, we should check the sorting criteria, so mode. We also need to do the drop delay. I will show you that on our system, it is possible to do the auto drop delay. But of course, if you feel more comfortable with the manual version is also possible on our system. Important is that before sorting, we will adjust side stream that they are reaching the opening of the vessels, so meaning collection tubes. So let's see first step, which we need to do. So you want to select the nozzle. Once the nozzle is selected, we want to install the nozzle on the sorter. And for that purpose, I would like to start the movie, which give me a second, because now I'm not able how I should if I declick, okay, the pointer, and now I hope, yes, you should see the movie. So
Yes,
first thing, okay, perfect. First thing, what you should we should do, we will insert the nozzle on the place where we insert the nozzle. We call it garage on our system. Each nozzle is, as you can see on the screen, is coming with the default settings. This is to simplify the life of the operator, meaning that those settings, nozzle settings, contains already selected information about drop frequencies, so how many drops per second will be created. They also have the plate voltage, pressure with which the desired or selected nozzle is working with. There will be also given information about drop center, which was selected previously. You can see also on the movie that you can yourself modify the amplitude. So adjusting the position of the first broken off drop. This is this turquoise line, or the light blue line is showing the drop center. You can also put the sort monitoring. Maybe most of you is familiar what sort monitoring means. This is also known as a sweet spot on some other instrument. So that will allow you to monitor the stable break-off point. So once this is done, you of course keep stream running. In the meantime, what you can do, you can check your experiment, or open existing experiment, or create the new one. And this is the example of the experiment. So those of you who are working already with our analyzer, you will see that it's like copy paste of the spectral flow which you have on analyzer. To those of you who are seeing first time our piece of our software, just wanted to explain you that here on the left you have a list of all your either reference control, so single stain, which we need for experiment, or multicolor samples. Below, we have acquisition control, where we can start, stop the acquisition. We can select the flow rate. And below, you will have the instrument settings. So each user can have own instrument setting depending on which type of the material she is working with. And here on this big worksheet, of course, you will design your whole gating strategy, either for analysis or when it comes to the sort, of course, the one among the guys, we will select the desired one or the one from which we would like to sort. Next step, just before sorting, we should do the drop delay. And for that purpose, I would like to show you the movie where we are using the auto drop delay. But as I mentioned, manual is also possible. So the window will open, the wizard. Now we can see how operator is placing the special bits. We call them spectral sort bits. So we take one drop into 200 microliter, and once the tube is placed on the instrument, we can start the procedure with drop delay. So at the beginning, it will do the initialization. After a few seconds, it will bring bits on the graph, as you can see here on the right. So we can see we should reach approximately around 4,000 events. And below on this black bar, this is the graph where you can see the steps of the measurements. We have 4 rounds. So with each round, the increment or steps are smaller to calculate properly the drop delay. And this green line, this is the line showing you the calculated for that round, the drop delay for that break-off point. Yeah, and now you can see that here in the drop delay adjuster window, we have the new value just calculated for today for the drop delay. Once this is done, next step, what we will do, we need to aim at the side stream, that they will reach the opening of the collection tubes, which we selected for the sort. And for that purpose, I would like to show you that we will do that with 5 ml fax tubes. And once the aim settings are selected, as you can see here, test sort is put on. We can see that we need to adjust the voltages to reach the frames. Frames, they are indicating the opening of the vessel, the one which we selected. As you can see here, the operator selected 4-way sort into fax tubes. And very nice feature is a live view camera, which is showing you here. You will see that you can double check that your side stream are really reaching the opening of the desired tubes. So this is how we can adjust the side stream. Next movie, which I would like to show you, is regarding the 96 well plate. So let's see, when it comes to the plate sort, you can select between normal and a high throughput mode. For that particular test, we will be using the normal mode for sorting on plate. Please don't be surprised that on the movie, in the live view camera, you see that the plate is with the lid. This is on purpose because we want to show you that sort was successful and we were able to sort the desired population of 50 events in the end should be into the well, but that is of course on the lid, just to show you that sort was successful. Once the sort is done, the pack with that plate will be moved to the load position. And now you will see that we were able to sort into all wells. Next one is to show you the sort into 384 well plate. You maybe notice that for that purpose, we use slightly different pack with the angle. So now the plate is on this lying with a certain angle. This is to be sure that the side stream is not hitting the wall of the well, but reaching the bottom of the well of 384 well plate. So this is the how the pack holding the plate is moving while you are sorting. So for that purpose, we open the door to show you better how the plate sort is happening. I hope that you like those movies, showing you a little bit, or at least a bit of how the life in front of the sorter looks like. Now I would like to show you that using our systems, you are able to transfer assays between analyzer and cell sorter. For that purpose, let me just put the pointer on back. So for that purpose, 25 color panel or kit designed by Cytek was selected. So that kit is also available on our website if you would like to have more information about it. And with that kit and with that assay, we want to go slightly deeper into subpopulation of T cells. And what we need to do to be able to transfer the assay from analyzer to cell sorter, of course, either you download the template from the analyzer, or if when it comes to this 25 color assay, you can download it from our website, import in the software on the cell sorter. You do the staining, of course, following the protocol. Next step will be you acquire all the single stain, all the reference control, a little bit also of your sort or the population, the sample which you would like to sort to be able to gate properly of the desired population. And if we would like to sort, then of course next step will be sort. However, this time what I would like to show you is the resolution between the analyzer and cell sorter. So at the top, you have the data recorded on the analyzer, and below is exactly the same tube, but recorded on the cell sorter. So you can see that the distribution of population is either identical or very, very similar between those two systems. If we will go slightly deeper into the subpopulation, we also see that we can keep the same resolution between different populations. And also, when we will look on the, for example, monocytes or basophils, you also see that all the population resolution between the population is kept, even if we will go to some population which have lower level of antigen expression, that resolution is kept between analyzer and cell sorter. So we can really see that the optical layout is really identical, and it reflects on the identical outcome between those two systems. With that, I would like to bring you to the section that we, of course, are able to sort on our sorter. And for that purpose, Cytek developed 28 color panel, which allows us to do the 6-way sort. So what we can see here, for that type of experiment, 6 populations were selected. So with the information how rare they are, this dark green numbers, they represent the density, let's say, of the population. In the light green circle, you see how deeply we can gate the population, or how deeply we can go with the gating. So in total, it is 64 gates. For that purpose, I would like to focus only on one population, which is the rarest population of those 6. So we were aiming for CD4 effector memory cells. And of course, after the 6-way sort, the purity was checked. And you can see that we were able to achieve above 99% of the purity, which I would say that for such a rare population is a very high number. Not only, of course, purity is the most important when you are sorting, because the functionality and viability of cells is also super critical for the user. And with the first assay, I would like to show you that we are able to keep quite high viability of cells after being sorted. For that purpose, another assay was performed on PBMCs, and we use the multi-way sort mode. 6 populations, as you can see, gated here with the orange gates, were selected for that purpose. And while the sort were finished, of course, we checked the viability. And here you can see the percentage of 6 population and in comparison to the viability before being sorted. And that shows you quite high viability. Next essay was to prove that the cells are the functional cells after they are sorted on our system. And for that purpose, we also selected 6 population. So you can see that we were looking on TCR gamma delta cells. We were also looking on NK cells, NK T-like cells. Then we also were going slightly deeper into CD8 TEMRA cells, effector memory CD4 cells, but also we were looking at CMV plus donor population. And the post-sort purity was checked for those 6 populations, so that we can be sure that we aim or we reach what we were aiming, that the population which we will be checking later for functionality, they are the one which we wanted to sort. So to be able to check the functionality of the assay, what was done, we split cells into 2 tubes. So we have some which were unsorted and kept for 9 hours, as you can see in the incubator. In the meantime, we were sorting other cells, which then were kept for 1.5 hours for the resting. After that time, cells were stimulated for 4 hours, as you can see, with PMA and ionomycin, and also breverdin and menosin. And after the stimulation time, of course, cells were stained with selected cytokines to get the answer whether we are working with the functional cells after sorting. And this is the outcome. So on the left, you can see that we were comparing CD4 positive population effector memory cells with sorted and unsorted. So the distribution of the population is very, very similar or identical. Here we also compared the very rare or even the rarest population, where we were looking for CMV plus CD8 plus tetramer cells, and looks on that after sorting, they were also as happy as the one which were left as an unsorted. Next 2 population were NK cells, where we did the comparison, and also TCR gamma T cells. Yeah? So again, when we look here, the pattern is very, very similar. And then the last, but also very important, were NKT-like cells together with CD8 plus TMRI cells, which also, when we compare 2 panels, one from sorted, one from unsorted, looks that those cells were also happy, meaning that we not only we are getting on our system pure population, but very critical for us is the information that those cells are functional cells, and then they can be used for further or downstream applications. And in the last section, I would like to show you an example that, as I mentioned at the beginning, we now on our cell sorter, we can have enhanced small particle module. That module allows you to focus, analyze, and sort small particles. With that, I would like to show you and also say that our system, cell sorter, is very flexible system because, of course, when you need to sort very unstandard material, you need to be able to modify different parameters on the sorter, meaning that, for example, the drop frequency will need to be changed. Pressure also maybe need to be adjusted to achieve the perfect conditions. And this is something what was needed to be done when it comes to the EV sort. Yeah, we selected for that 70 micron nozzle, but we, of course, adjusted those parameters like frequency and pressure to be able to perform the sort of EVs. Of course, before sorting the EVs, which in that case, there were two populations. One population was EVs and derived from red blood cells. The others were from the platelet. Both populations were stained. Before that, all the desired necessary controls were run. Among them, of course, as you can see here on the screen, for example, ultra pure water or different dye controls. As I mentioned, two populations were sorted. That was our aim for that particular sort. And here I would like to show you the outcome that again, of course, post-sort, we did collection of different buffers, different controls, and the most critical was that we also check the purity of the sorted EV population. At the top, you see the red blood cells EVs, and below we have the one coming or derived from platelet. So I hope I could show you that a small particle sort on spectral cell sorter is doable with the enhanced small particle option or module, improving even the resolution. And with that, I would like to summarize about the Aurora cell sorter system. I hope I could show you that on the spectral cell sorter from Cytek, you keep all the benefits which Spectral is giving you, meaning the one which first, of course, Cytek developed for the analyzer, like autofluorescent extraction or multiple autofluorescent extraction, flexibility when it comes to the fluorochrome's choice, that all is kept and transfer on the cell sorter. You have possibility to sort into different vessels on our system. Additional features appeared on the cell sorter to be 100% matched to the analyzer, not only like hardware features like ESP module, but also in the software. Hopefully, I was able to convince you that the optical performance is kept and is exactly the same between analyzer and cell sorter, and that you almost with one click, you can transfer your assay between analyzer and cell sorter from Cytek. So thank you so much.
Thank you, Marta. That was very nice presentation. I have to say also new data for me about EV sorting. Very, very nice and impressive. So I'm looking forward to try myself. And I hope that there will be some questions or any curiosity, any comment, maybe from Lydia or from Petar, if you like to ask anything, if you have any, Lydia, any plan for your facility to have a high-end cell sorter in the near future. So we are happy for any questions.
Well, hello. First, thank you very much for a nice presentation. I don't have any questions at the moment. I was also impressed with this EV sorter. I mean, I didn't know that's well possible and in this way. So it's very impressive.
Thank you.
So thank you.
Yeah. As mentioned, that is also, you know, a new feature, new possibility on our sorter. Yeah.
Yeah. So very interesting. Thank you.
Thank you.
Okay, we will send you maybe just some more follow-up information via email. Some updated technical specs, so we can be in touch. And Petar is raising hand, so please, Petar.
Hi again. One question. Is it possible to organize some kind of real life presentation where we can bring some people there or whatever? Do you have in your facility?
Well,
Ricardo?
yes, if I think about geographically speaking, the closest sorter actually bundle installation we have in Zagreb, the infectious disease hospital.
That's great.
We have a bundle of a cell sorter and analyzer right now. It's a relatively new installation, so they are getting some experience because, of course, I'm sure they could be a very good reference point. But we can speak maybe after summer, during autumn, about some kind of activity. Depends also what's the plan. Yeah, so Petar, we can talk about this
Okay, thank you
separately.
very much.
So the information it's also for Lydia, which is nearby, that we have in fact
yes,
nice bundle installation.
We are all close.
Yeah.
Okay, thank you.
Right. Okay, so then thank you for joining, and I will share some more follow-up information with you. And thank you, Marta, for your time. It was
with
very
pleasure.
Nice. It was very nice,
Pleasure.
and the video and the slides and new slides about TVs, very interesting. So I wish you a nice day for now, and we will be in touch.
The same to all of you. Thank you so much. Bye bye.
Bye bye.
Thank you.
Bye.
Bye bye.
Bye.